really do anything else about it. So I want to talk a little bit about how you see that and how you find that. Let's say you just have some generic alkene, and you want to know if it's cis or trans. First, you have to know what those definitions are. So cis means same, and trans means opposite. So you have something either the same or something opposite. And the way you look at that,
Which one means which?
I'm going to write it down here.
Okay.
Cis means on the same side and trans means on opposite sides. And what the sides that this is talking about is the plane of the double bond. So what you do is you draw kind of a line or a dotted line or whatever through parallel to the double bond. And cis or trans really only applies to things that are the same. So the things that are the same in this double bond are the hydrogens. There's a hydrogen here, and there's a hydrogen here. We drew that dotted line through the double bond. If those two hydrogens are on the same side of the line, then that's cis. If they're on opposite sides of that line, then it's trans. So what is it in this case? It's got to be trans because the hydrogens are on opposite sides of that red dotted line. Try another one. Now, we don't always specify cis or trans in a ring, like a cyclohexene, but we could just the same. So same idea. We draw a line through the double, parallel to the double bond. So you're not crossing, like cutting the double bond, you're drawing it with the double bond. And then you're looking at the hydrogens usually. It's not always hydrogens, but because the two things have to be the same, it's usually hydrogens. Now, are those two hydrogens on the same side or the opposite side of that line? Same. So this is a cis double bond. Where this becomes important is usually in straight chain alkenes, sorry. Like this. So take a look at these two alkenes. Now, how would you name the one on the left? What would be the name of the one on the left?
Pentene.
Right, 2-pentene. And what would be the name of the one on the right? Same thing. That's also 2-pentene. But that's actually a problem because those two aren't the same. So that rule that we talked about in the quiz of like, well, if they have the same name, then they should be the same. That's a problem here because that double bond doesn't rotate. So we can't just make a model of that first one and kind of flip around that right side to make the second one because the double bond doesn't rotate. So those are actually a special kind of isomers called stereoisomers. You need to know that word. But they're the cis-trans or trans-cis isomers. So one of them is going to be cis-2-pentene and one of them is going to be trans-2-pentene. So see if you can figure out which one is trans and which one is cis using that same technique that we just looked at. All right, so what do you think? Which one is, say, trans? The first one, agree? Disagree? Yeah. So we would actually put that right in the name, and this one would be called trans 2-pentene, and this one would be called cis 2-pentene. And that's all there is to that. Now, the reason cis trans usually isn't important in a ring like this is because there is no such thing as trans cyclohexene. Because if you tried to have a trans there, that would mean this would have to like connect over. You see how like it wouldn't be possible. That thing would have to stretch out weird to do that. So we don't have any alternative. So you won't usually see cis or trans in small rings like that, because they're just, the trans one usually just doesn't exist. But it is important when you have straight chain alkenes like this to specify which isomer you're talking about, the trans isomer or the cis isomer. And those are often totally different molecules in terms of reactivity, in terms of boiling points, physical properties, all that stuff. Those would not necessarily be similar at all. So it is an important designation. All right, you feel better about that? You can probably do that. Okay. So this won't be on the exam on Wednesday, but will show up next week on the quiz and then on the final. All right. So what do you want to talk about now?
This isn't really like related to your test question, like you're not doing anything in terms of like dropping one of the worst exams or anything, are you?
Yes. Your worst exam will be replaced by your final exam score if it's better.
Okay, so it's like the best 3 out of 4, including this in the final.
Right.
Okay. Is the final going to be roughly like as long as all of these exams have been, or will it be like twice as long? Or?
It'll actually be shorter because the final exam periods, it doesn't really affect us in the night class, but the final exam periods are an hour and 45 minutes or 2 hours and 15 minutes. They're not as long as a full 2 hour and 50-minute class that we have. So the exam won't be quite as long.
Okay.
You know if it's all multiple choice or will there be written work?
Um,
So you mentioned you were going to talk about it.
yes, I don't know for sure. I believe it's all multiple choice.
How about one where it's actual credit?
Maybe.
Except for the final test and multiple choice extra credit.
I like it. Okay, so like this is just like the normal like layout. Yeah. Because it has all of this hydrogens burned in it. They're very cheap. Okay, so. So for this right now. So it's got less hydrogens than
Can we review what on the schedule just to make sure?
Yes.
So this Wednesday is the exam.
Yep.
The following week, Monday is the quiz.
Mm-hmm.
And then when's the final? Is it Wednesday? Because it says the 14th of December.
No, the final is the following week.
So the 9th.
The
The 14th.
Because it says the finals of the 14th. So I just wanted to.
the week of the 14th is finals week. So yeah, we will have our final the night of the 14th.
Okay.
So like same time we would meet.
Same time, regular class, same room.
So the night, are we doing lab or is it like review or final?
Both. We'll be doing that nuclear lab that we skipped before, kind of all together as a class. It doesn't take that long, so we'll do both.
So does our lab do this Wednesday? Right?
No, actually, I mean, turn it in whenever, but labs are technically always due at the next lab, which is next Wednesday. So if you've got it done, great. But if you don't, you can turn it in next week.
So then, if our final is on the 14th, I'm assuming we have nothing to come back for on the 16th.
Right, that's just exam week, so there's nothing there. If, yeah, no, there shouldn't be any reason to be back that week.
So so the following Wednesday then, what exactly, it just says checkout, what does that mean? You said?
Right, but we're gonna do the lab that week, so there's gonna be a lab also.
Are you gonna like review for the final? Or
Yeah.
like give us a review or something?
Yeah, well, I'll same kind of like what we're doing here, I'll answer
And we're
questions.
doing the nuclear lab then?
So the quiz on the 7th will be over.
The rest of the organic stuff that
Like,
wasn't
so
on
the
this,
second half of.
Yeah.
Okay.
the reactions and,
So it's like 16 through 24, what we're not, but it's not.
right, well, and the stuff we did today also, so the naming and things, it'll kind of be more with the whole chapter. Bring a calculator. You can bring your notes in your bag or, written on your hand. Don't do that. No, just bring a calculator. And actually, I said the room would be here, but I'll actually have to let you know about that. I'll post that because rooms might be weird for exam week. So it'll either be here or the lab, but I don't know which one. It won't be like some random room in a different building, but I'm not sure which room it will be.
What time a notebook?
Yeah, it's a good thing to bring to class.
Can we just review molarity?
Yeah, let's look at molarity. What's the definition of molarity? How do we calculate it? Yeah, molarity is moles per liter. That's an important definition to know. You'll definitely have to do those kinds of calculations on Wednesday and then again on the final. We did on the last exam as well. So usually this involves converting to or from moles to or from grams. So if you have like, let's say 25 grams of sodium chloride in 3 liters of solution, we want to know what the molarity of that is. And whenever I asked this on the last exam or something like it, people tended to just divide 25 by 3. That seems to be kind of a general trend that if somebody doesn't know how to do a problem, they just either multiply or divide the numbers that are in the question and sort of see if they get lucky. With multiple choice questions, that's a bad strategy because usually that will be one of the choices. So you have to know what you're doing. In this case, if it asks for molarity, you should know that you need to have these units. You need to have moles per liter. What we're given instead is grams and liters, which means the grams need to be turned into moles before we can do the calculation. To find that, we have to do that conversion, so 25 grams of sodium chloride. And then we use the molar mass to get grams of sodium chloride in 1 mole of sodium chloride. So we look up that molar mass, that's 23 plus 35.5, which is 58.5. We can calculate that. So that's 0.43 moles. That is still not the answer. That is just the moles. But now we have moles, we can divide by liters and get molarity. So if molarity is moles per liters, we take the moles we divide by the liters. And get 0.143. And so that's the concentration, that's the molarity, 0.143 molar. The biggest, as I said, the biggest mistake I see with these problems is not doing the conversions from grams to moles. If it says molarity, you have to use moles. If it's percent concentration, like mass percent or volume percent or something like that, then you don't need that. But we don't even use those concentrations very much in this class. We usually always use molarity, which means that the mass has to be converted to moles before you can do that calculation. Is that helpful? The other part to molarity is if you're given a molarity, you can use that to calculate moles or grams. So let's say we have a 2 molar sulfuric acid solution. How many moles of sulfuric acid are in 25 milliliters of that solution? So we can figure this the same way. Once again, we need to know that definition, that molarity is moles per liter. That tells us that 2 molar solution tells us that there are 2.0 moles of sulfuric acid per every 1 liter of solution. Now, we're asked how many moles are in 25 milliliters. Well, another way to write this, since we know this conversion, is to say that there are 2.5 moles in 1,000 milliliters of solution. And we can multiply that then by that volume, 25 milliliters. The milliliters cancel. And we go 2 divided by 1,000 times 25. So 0.05. So there are 0.05 moles of sulfuric acid in 25 milliliters of that solution. If you want more practice with this, jump to chapter 9. And you'll see a bunch of practice problems in the section on molarity. We'll get some example calculations. And then try to find the here. And then a bunch of problems about, so you can skip these ones about mass to mass and mass to volume, but go to these talking about molarities. These are all the same kinds of practice problems. Molarity, asking you to solve for molarity, solve for moles, solve for grams, whatever. If you can go through and do all those, then you know you're in good shape when those come up on the exam. This will be a huge part of the exam because we did this on the previous exam, but because it also applies to acids and bases, it will be coming up a little bit, and it will certainly be in the final. This one's a video. Well, let's take a look at the chapter objectives from the other two chapters and see if there's anything that strikes you on that. So you're good with these nuclear things? No. I just thought you were cold. Oh, I had that up.
Can we do like a half-life one?
Yeah. Let's pull one out of the book. Oops.
So the exams, practice, the exams that you have to master,
Mm-hmm.
are those good to like go into and do them with like the homework or?
Yeah, those aren't totally complete because we're always going at a little bit different pace, so those might not have everything that we have gone over, but
Some of the stuff.
it's a good way to test yourself on some of that, yeah. All right, so let's take a look at this one. This one's a little tricky because it is a little more abstract rather than looking at specific numbers. We're looking at strontium-85 with a half-life of 65 days. How long will it take for the radiation level to drop to 1/4 of its original level? So you have to think about what it means for a half-life, and then how does that apply to these others? How'd you figure 130 days?
I did 65 and 65.
Yeah, because each half-life cuts it in half. So if you cut something in half, you have half of what you started with. If you cut it in half again, you have 1/4 of what you started with. So it's going to take 2 half-lives to get to 1/4 of its original level, which is 2 times 65 or 130 days. And that, as we discussed in class before, that's the trickiest part of these half-life problems. You want to just kind of divide things evenly. You want to say, oh, 1/4 of its original level, well, that must be 4 half-lives. But that's not how it works because each half-life cuts it in half. So that means that you'd get to 1/4 in just 2 half-lives. And then how long would it take for the radiation level to drop to 1/8 of its original level?
Do you mind drawing it out for me? I'm more of a visual person.
Sure. Did anybody have pie last week? No. Any good pie? What kind of pie? Apple pie? Okay, let's pretend this is apple pie. I'll draw a crust and some of those little hole things in front. Okay, there's our apple pie. So after 1 half-life, how much pie is left? It's half, right? That's what half-life means. So after 65 days, we've lost half the pie. Some crumbs, maybe. Okay, so half the pie is left. The rest is just the tin in 65 days. In another 65 days, we lose half of what is there now. If we cut what is left in half, we have this. And then another 65 days, we cut that in half. There's just one little sad piece of pie left. So this is, we could say 1 or the whole. Then we cut it in half. Cut it in half again, we get a quarter. Cut it in half again, we get an eighth. So we get to the 1/8 of the original in 3 half-lives. 3 half-lives, 65 days each. We multiply those together, and I think it's 195. We can draw that too. So the total time after 1 half-life is 65 days. After 2 half-lives is 130 days. And after 3 half-lives is 195 days. And so at each 65 days, cut in half. What was the half-life of the pie that you had? How long did it last before half of it was gone?
Like 2 days.
Okay. Is that helpful to see it?
Yeah.
Trying out like that? Okay. And that, I think that is the best way to do these kinds of problems, is just draw it out. Draw out the numbers, as we've done in some other problems. Draw yourself a picture, like a pie chart or an actual pie, or however you want to think about it. There's no advantage to doing it in your head. You've got paper, you might as well draw it out. Make sure you've got it right. The other way we can do it is from the data. I don't see an example of that here, but we could say a 200 milligram sample decays to 25 milligrams in 18 hours. What is the half-life? So that's another way of asking, kind of the backwards way of asking that question. A 200 milligram sample decays to 25 milligrams in 18 hours. What is the half-life? So in this case, we would do the same thing. We'd count it out. How many half-lives does it take to get from 200 to 25? So you cut in half each time. 200 to 100, cut in half once. 50, cut in half twice. 25, cut in half 3 times. So from 200 to 25 is 3 half-lives. If that's 18 hours, how long is 1 half-life? Yeah, 6 hours. So you count it out, you see that's 3 half-lives, 6 hours. Now what a lot of people will do in a problem like this is they'll divide the 200 by 25. If you divide 200 by 25, you get 8. So then you think, oh, okay, 8 8 half-lives and you divide this by 8, get some weird number. That's not the right way to do the problem because you're cutting it in half each time. You're not just decreasing by a particular amount each time. You're cutting the whole thing in half each time. So make sure that you do that. All right, what else we got?
Can we do an acid and base problem?
Yeah. Any sort in particular?
No.
Okay. Like, just look at some of these questions at the end here.
Like these.
Like these?
Any of them.
Any of them? Okay. Let's look at
Hard.
a hard one. It's a hard one. I don't like these. But you should certainly be able to determine pH based on different concentrations. We've done this a few times. So what would be the pH of A? Eight, right? Yeah, because it's the negative log, which is the negative of the exponent above the 10, assuming that the other number is 1. So this is just the negative log of 1 times 10 to the minus 8 is 8. If you didn't know that, you could plug it into your calculator and just take the log and then switch the sign. And that's how we'll do this next one. This one isn't just a nice even number. So it's not just 10 to the minus 2. So the answer is not just 2. It's 5 times 10 to the negative 2. So we have to pull up a calculator with a log function on it. All right, and 5 times 10 to the negative 2, I'm not sure how to enter that on this calculator. I don't think there's like an easy way to do that. So I'm just going to convert that to standard notation. That's 0.05. That's 5 times 10 to the minus 2. And I'm going to take the log of that, log, and get minus 1.3. Then we have to flip the sign because it's the negative log. So the pH of that is 1.3. So this one's 8, that one's 1.3.
So it's always the opposite?
Right.
If it's negative,
Right.
then you-
Now, yeah,
Sorry, can you do B again? What did you do?
yeah, I took 5 times 10 to the minus 2, which is
Yeah.
0.05, and I just took the log of that, and then I switched the sign. If you have a graphing calculator or something, you can just type in negative log of parentheses 5e minus 2, but if you just have a regular calculator, you just hit log of whatever. We won't have these exact type of questions on the exam because you're not required to have a scientific calculator. So when you have to calculate pHs, as we've done on the quiz, I think, you will only have to do it with like even numbers with 1. Yeah. All right, so the last two, C and D, give you the hydroxide concentration instead of the hydronium concentration. Do you ever remember what the difference is there or how you deal with that? So if you take the negative log of the OH, then you get something called the POH instead of the pH. We can deal with that because the POH and the pH have to add to 14. So we can find this one and then subtract 14 from 14. So 3.5 times 10 to the minus 4, that's 0.00035. And we'll take a log. So it's going to be 3.46. The pOH is 3.46, which means the pH has to be 14 minus that, 10.54. They have to add to 14. So the pH is 10.54. Same thing here, 0.005. Take the log, get minus 2.3. So the pOH is 2.3. That means that the pH has to be 11.7, so that they both add to 14. All right, what other kind of acid-base stuff should you know?
Are we gonna have, like, when we have to balance equations and name what they are?
Yep,
Can we do that?
sure. So first, let's just try to complete the equations. So if you see equations like this, what do you have to know to be able to balance them? Or to be able to write the products?
The type of thing it is.
Yeah, you have to know the type of thing it is. In this case, what types of reactions are these?
Double replacement.
They are double replacement, but what's even a better way to classify them? That helps us understand what the products are. Maybe double replacement is good enough. But yeah, they're also known as neutralization reactions. So if you can recognize that that first one is an acid, being a H, something that starts with an H, and the second thing is a base because it's a hydroxide, then we can say, well, these are going to kind of trade places like a double replacement, but one of those products is always going to be water in a neutralization reaction. So that means we can write water.
Wait, and you know that because there's an H and an OH?
Yeah, because it's an acid and a base. One of these is an acid, phosphoric acid. That's one that you should know the name of. And the other one is a base, calcium hydroxide. Hydroxides are always bases. So the acid and the base react, form water, and then we have to make a new compound from whatever is left over. So the H goes with the OH to form water, and that means that the calcium has to go with the PO4. But we can't just stick those two next to each other because we have to make sure to balance the charges, just like when we're naming and writing compounds from names and all of that. So what should be the formula of a compound made from calcium and phosphate?
Ca2PO4.
Close. What's the charge of phosphate?
That was 2 minus.
No, not quite. Just check that list before the exam. But another way you can figure that out is look at the compound that's given. Phosphoric acid is H3PO4. What's the charge of hydrogen? plus 1. Hydrogen's always plus 1. So what does that tell us that phosphate has to be? 3, minus 3. If hydrogen is plus 1, and there's 3 of them in the compound, then phosphate has to be minus 3. So that tells us that we need to make a compound from phosphate, which is minus 3, and calcium, which is plus 2. So that compound is going to be Ca3PO4 So we have 3 of these to make 6 plus total, 2 of these to make 6 minus total. We're not going to do the second one because it's kind of tricky. I'll show you the answer, but it's one that we didn't really talk about. What happens when this is potassium bicarbonate. What happens when you add an acid to a bicarbonate? Anybody know? We didn't really talk about this, but you might have seen it in your life before.
Should we balance the top one?
Oh yeah, let's balance the top one first. And we'll go on to that. All right, so to balance that, we've got 3 calcium on the right and 1 on the left, which means we need 3 of these. Then we've got
9 each?
9. Yes, nine hydrogens on the left, but we're gonna save those for a second because they're in a couple different things. So we don't want to balance those first off. Let's balance the phosphates first. We've got 2 on the right and 1 on the left. So we need to put a 2 here. And then the best way to finish this up is to balance the oxygens, but only the hydroxide oxygens, because the phosphates were already taken care of. So from the hydroxide, we've got 6 oxygen. And that means we're going to need 6 of these, because we need to think about how these things went together. These H's went with these OH's. So that means that those are becoming this part. We don't need to mess with the oxygens in there. And so that should keep everything balanced appropriately. Right? Yep, 12 hydrogens total. So anyway, the second one, we didn't talk about this, but bicarbonate, when you add acid, forms carbon dioxide. So I would use it in baking because it forms bubbles. So usually there's some kind of an acid with the baking soda, like have you ever used baking powder? You ever know about baking powder? Baking powder is baking soda and acid, and some different acids, tartaric acid and some other stuff. So citric acid. So when the acid and the base combine, and the base is a bicarbonate, it produces bubbles, kind of like the vinegar and baking soda thing. And that's what makes your cakes get, nice and airy and stuff like that. So not yeast stuff, that's different. But that means that this reaction is a different kind of a neutralization reaction that produces water and also carbon dioxide. And then the byproduct here is potassium nitrate. So these bicarbonates and carbonates always break up into carbon dioxide. But we didn't talk about that, so we don't need to know that.
Can we do a naming? Or
Yeah.
like writing?
Yeah. Let's try another one of these acid-base equations, but just from the names. All right, see if you can write a balanced equation for the reaction of sulfuric acid and aluminum hydroxide. What's the symbol for aluminum if you don't have a periodic table with you? Yeah. That's Al. Yeah, number 13. So see if you can actually write this down as though this were an exam question. See how you do. I'm not going to look at it, but you can. Yeah. The random auto-playing videos. So anybody got this yet? Still thinking about it? You may want to come write an equation up here. Or just tell me.
Just tell it.
Just tell it to me. Okay, what do you got?
3H2SO4
Yeah.
plus 2 AL parentheses OH and parentheses 3
Okay.
0 6 H2O plus AL2 parentheses SO4 and parentheses 3.
Okay, thanks. What do you think? Nodding your head? Yeah, so you got it? Yep, this looks good. So we need to know a few things here to be able to write this. We need to know the formula for sulfuric acid. There was that list of several acids that you should know the formulas for, and like H2SO4. So not knowing sulfuric acid is H2SO4 is going to set you up for some problems in this. I think that came up in the last quiz where it was asked for something about sulfuric acid, and I saw a lot of them that just said things like H2S. So make sure you know those acids. Also, you need to come up with a formula for aluminum hydroxide. So you need to know aluminum is a +3 ion from being in column number 3, group 3A, that is, and hydroxide is a -1 ion. Therefore, you need 3 of the -1 hydroxides to balance the +3 aluminum. So once you've got those two, we recognize this is a neutralization reaction between an acid, sulfuric acid, and a hydroxide, aluminum hydroxide, and therefore is going to form water, as well as then whatever else is kind of left. So the H goes with the OH as before, and the aluminum goes with the sulfate as before. We have to come up with a new compound that has the properly balanced charges. So if aluminum is +3 and sulfate is -2, we need 2 aluminums to balance 3 2- sulfates. Because you need 6+ and 6- overall. If you're still not comfortable with this kind of stuff, please go back to that chapter for whatever it is, and look through that, because it'll be on this exam, it'll be on the final. You need to be able to do this.
Do you remember what notes section the list of acids?
Yes. Well, let's find it. No, actually, I don't, but let's find it. I believe it's
Organic and molecular compounds.
8.
Yeah, 8.
Notes 8 right here. Second page, naming acids. So there's the acids that we talked about. Acids are a little different from the regular naming stuff, so I'll make sure you know this. Yeah. No, chapter 10. Right? It's notes 8. It's chapter 10.
Okay.
Other things? Questions?
Can you do another example like that,
Sure.
please?
All right, so same question. Well, let's reword it a little bit. So let's say which acid and base would react to form water and barium chloride? Write a balanced equation. So it's kind of the opposite question. You're given the products. Say you can come up with the acid and base that react.
Is barium BA?
Yes, barium is Ba, number 56. You get an equation for this one? Water, of course, is H2O. Barium chloride, BaCl2. So then what things must have reacted to form those? Well, what's going to be the hydroxide here? Yeah, it's got to be barium hydroxide, which is PaOH2. Barium being +2, hydroxide being -1. The reason we know that is the hydroxide is not going to go with the chlorine. It always goes with the metal. The chloride is then going to go with the acid, which is H and Cl, makes the compound HCl. So the acid is hydrochloric acid. The base is barium hydroxide. That's going to make water and barium chloride. So we need to balance this. Which I think is just like that. Yeah.
So the first one will always have an H and the second one will always have an OH.
Well, the acid will always have an H and the base will always have an OH. It could be written in the opposite order, but yeah. All right, so other things before I fall asleep? Everybody feels good about this?
It's not just chapters 10 and 11, right?
5, nuclear chemistry, and others. I mean, naming and everything is still on there too. But yeah, it'll focus on those 3.
I'm sorry, I didn't hear that. What is it focusing on?
The 3 chapters we've done since the last exam, 5, 10, and 11.
For the final, I was wondering if I could take it, is your other class taking it earlier in the day?
No.
A different day?
Yeah.
Can I take it with them? When is it? On Wednesday?
But
Is it on Wednesday?
no, it would be. I have to check the schedule, but I believe it would be Tuesday afternoon,
Could I take it
early
then?
afternoon, probably.
Or earlier in the day on Monday?
I won't be around earlier in the day on Monday, but Tuesday.
not,
Let me
it's
check
okay.
the time
Okay.
on Tuesday. There will be an exam at some point on Tuesday. I'm not sure exactly when it would be,
It doesn't matter to me what time it is.
but yeah, sometime in the afternoon on Tuesday.
So is it okay that I do that?
Mhm.
Will you tell me for sure when it is on Wednesday, like at our test?
Yes, because I'll be
Or we
telling
could like
them
look it up
tomorrow.
online or whatever?
Right,
Okay.
you can look it up in the
What time is that class
schedule.
that you normally have
Well,
it?
let's
and
just
then
do it
I'll-
right now. I can.
Oh, okay.
It's on the thing.
Thank you.